brackets out if you haven't already. And section 6.6 is about function operations. And this is one of those childhood memories. I grew up on a dairy farm, and so electric shocks, they happen quite a bit. I remember when there were storms and the weeds and things would hit the electric fence because we were little and we couldn't do a whole lot. Mom and Dad would say, go walk the fence. So what we'd have to do is walk around the fence until we found the big weed that was hanging on the electric fence so it wasn't working. And then we'd pull it off. Now, if it was wet, you'd, of course, get yourself a nice little zap from the electric fence. And when we were really little, we could just duck to get under the electric fence, you know, so we'd go like this, and we could go under it, and no problem. But one day you realize you grew just a little too much, and you'd go under the fence and zzz, right in the back. Not good. This always reminds me of that. This game is still around. Have you guys played this one? Yeah, it's that electric game. If you haven't done this before, maybe you've seen it on TV. It's that electric game where you're supposed to take the little tweezers and pick out the apple and the bone and stuff. And if you touch the sides, you get that little zzz noise. And that always reminds me of that electric fence. But we're talking about operations. It's just not the kind of operations you would think about when they say the word operation. We've got add, subtract, multiply, and divide. And tomorrow you learn a new one. Secret. Probably shouldn't have said that. Tomorrow you learn a new one. Add, subtract, multiply, divide, and something new. So, function operations are what we're going to be going after. Our objective is just the top one today. We're going to focus on add, subtract, multiply, and divide functions, which at this point maybe you're saying, that's not new. We've been doing a lot of that stuff. You're right. But we're going to have a new focus today. That new focus is on what's called the domain. The domain is responsible for telling people about the x values that they can use in a formula. So the input values that they can use. And if you're thinking, well, can't you just put any old number you want in any formula? No, not always. So what we have to do is say, okay, you can use our formula, but we need to warn you. Don't try to put these numbers in, because they're not supposed to go into this formula. So you start to think, well, how are we going to know when a number can't be used in a formula? Two situations. That's all we have to remember. There are two situations where we have to do what's called restricting the domain. This is one of them. Division. There's nothing fancy about the 4. But right now, we would have to tell somebody there's one number you cannot put down there for x. What number is it? 0. It's out. So we'd have to tell them x can't be 0. And that's what that strike through equals means, is it can't. Put anything else you want in there, but don't you dare put a 0 in there, because then it'll be undefined. Now, we may see division like this. Now, 0 is not a bad number, but there's still a bad number because there's division. What number, if we put it in there, would make this undefined? 5. So we have to tell them. We have to give them the warning. Don't use 5. Anything else is good. That 5 looks kind of weird. Any other number, you're good. But we can't divide by 0. So that's the first situation. The second one, when we started chapter 6, they said, only think of the real number set. No imaginaries. So, if we see anything with an even root, we have to warn people. You can't put negatives in there. But in math, we're kind of lazy. We don't like to write out words. So what we do is we figure out a way to represent, hey, don't use anything to the left of 0 on the number line. You can use 0, because the square root of 0 is 0. And we write it as x can be greater than or equal to 0. Now that gets a little more complicated when they start putting something other than x down there. So let's say they give us the fourth root of x plus 1. Well, now the cutoff changes because we want to know when is x plus 1 going to be greater than or equal to 0. Otherwise, we're taking the square root, the fourth root of a negative number, and that's imaginary. So we just solve this little inequality, and we would let people know, hey, you can use all the numbers from -1 to the right forever, and you're okay. Put anything else in, it's undefined. Can't do it in the real number system. So most of our time today is going to be spent talking about the domain. Yes, we're going to add, subtract, multiply, and divide, but the domain is the new piece. And we really are just looking for two things. Could we be dividing by 0? If we could, what number would make it bad? Could we be taking an even root of a negative? Then we got to warn people, hey, don't put these numbers in. Those are the two things we watch for. Now, to start with, I like this example, but I want to talk to you about a real-world situation, and then we'll do this example. It had to be a good 10, 15 years ago. At the Albertville Outlet Mall, love that place, there was a store called Izod. And Izod is a golf store. So they had clothing for going golfing. They had sweatshirts and t-shirts and polos and just all kinds of fancy things for that. But it was Black Friday. And in their window, it said, today only, 70% off everything. Wow, that's a really good deal. But a week before Black Friday, they sent another flyer out, and it said, in addition to 70% off everything, if you come between 6 a.m. and noon to our store, you will get an additional 20% off. 70% off. Go to the store. Another 20% off. I'm walking around the store and I'm thinking everybody in my family is getting a new sweatshirt today. This is a good sale. And there are people that are walking around the store and you can hear them talking to each other. 70% off and another 20% off? Does that mean we get 90% off? Wow, this is a good sale. And the people that work there, I was so proud of those high school people that they had working there. Because they were walking around listening to those conversations and they said, it's not 90% off. It's still a really good deal, but it's not 90% off. Because those same people would have been really angry if they had gotten up to pay at the register and found out, it wasn't 90% off. I start with that because that's what I'm going to end with today. We're going to calculate that and figure out 70% off and another 20% off. How much do you really get off? This. Getting ready kind of goes along those same lines. You want to buy a sofa that's already been marked down by $100. You saw that in the paper. You know they have a break on it here. The furniture store may add 5% sales tax before applying the additional discount. So you got to the store, you already know they lowered the price $100, and you see this little tag. Take another $50 off. Ooh, it's even cheaper. But you have this tax there. So, would you want to figure out the tax first and then take the discount? Or would you want to take the discount and then get the tax? And is one of those ways better for you or not? Well, it used to be this happened all the time. JCPenney's was really famous for, they'd give you a discount of a percentage off and then they'd send you a coupon. And when you got up to the register, it wasn't a scan thing. This was, again, before you guys were alive. There was an actual person that did the math and punched things in. And they would ask you, do you want me to do the percentage off first or do you want me to do the coupon? There is an advantage one way or the other, but you had to know that. They don't do that anymore. Menards was kind of the last holdout. They used to let you pick, and within the last couple of years, they've told all their cashiers, you always do it this way first and this way second, so that you don't get a choice. We're still able to choose here. So what I'm going to do is I'm going to make up a number that would be really nice to do math with. Let's just say that it started at $1,100. So you saw it in the paper for $1,000. Kind of an expensive sofa. Must have the recliners and leather and all of that. So $1,000. So you walk into the store and you see the $50 off. So you start thinking right away, I'm going to take that $50 off first. So now it's down to $950. Oh, yeah, you can't eat a sofa, so you got to pay tax on it. So we'll have to add that 5% sales tax. So we do 5% of $950. And because my Smartboard TI emulator has been crashing everything, I'm using the TV up there for this now. So $950 times 0.05, $47.50. So it was $950 after your discount. You're going to add the tax. $997.50. That looks uphill. I better try and make that a little bit straighter. There we go. But you get up to the checkout and the gal says, well, do you want the discount first or do you want the tax first? Well, then you do what any educated consumer does. You grab your little calculator from your purse, because you should always have, just even if it's a dollar store calculator, a really basic calculator in your purse. And you say, well, let's see. If I did the tax first on $1,000, 1,000 times 0.05, well, all you do is move the decimal place 3 places to the left, because this has 3 zeros and you'd get $50. But let's just say you had your calculator handy. You'd see it, $50. So now we're at $1,050 with sales tax. And then you remember, oh, wait a second, there was this little sticker on it. It said I get $50 off. There's an advantage here. Discount first and then tax saves you money. And while you may say, well, that's not a lot of money, it's your money. You know, walk out of there with enough to buy yourself a Coke. Be good. Your money, you want to make sure that you're trying to figure out the way it should go. The only place that I've seen in the last 10 years that still lets you do this, if you go to college, the college bookstores sometimes let you do this. So sometimes they'll say, do you want our 20% off first, or do you want to use your coupon first? And so you want to calculate those things before you go in so you know which one of those is to your benefit. So in this case, we want that discount of $50 off first. Then we want the tax. And that's kind of, like I said, I'm going to end with talking about the IZOD example today, and tomorrow will be more about that, being an educated consumer. So the final cost of the sofa in the Solve It involves 2 functions. One that gives an additional discount, $50 off, and another that multiplies to find the sales tax. So we have subtraction and we have multiplication, which brings us to the part of the objective we're supposed to do today, which is our essential understanding. We can add, subtract, multiply, and divide functions based on how you perform these operations for real numbers, which I hope right now you're like, we've been doing that, because we have. We've been adding, subtracting, multiplying, and dividing all kinds of things. Our difference, what we have to focus on today, we have to consider the domain of each function. It's like a warning to people, hey, use these numbers. These numbers are going to work great. So our key concepts here have to do with function operations of addition, subtraction, multiplication, and division. Pardon me. You're going to see, we already know how to do that math. We do. It's not new stuff. But what we have to do is focus on telling people, warning them about the domain. So for addition, all we're going to do is they're going to say, add the 2 functions f and g. We're going to combine like terms, because that's how we add. They're going to say subtract. We're going to have to be a little more careful, because the most common mistake made in mathematics is forgetting to distribute a negative. So we'll have to be a little careful there. Multiply, we already know how to do that. Divide, we know how to do that too. Learned all these things over the years. But notice this. that is actually a domain restriction right there. Because you're warning people, hey, this is g of x down here. Don't you let that be 0, because it has division. And you can't divide by 0. So it says the domains of the sum, difference, product, and quotient consist of the x values in the domains of both f and g. So we're going to talk about the domain of f. We're going to talk about the domain of g. But what we're really interested in is when we put them together, what numbers work in both of them, not just one or the other. It has to work in both. Also, the domain of the quotient function does not contain any x value that would make that denominator 0. Yeah, that's part of it. You can't divide by 0, and you can't take negative even roots. Doesn't work. Won't be in the real number system. All right, so problem 1, adding and subtracting functions. Let f of x equal 4x plus 7, g of x equal the square root of x plus x. What are f plus g and f minus g? What are their domains? So here's what we're going to do. We're going to start at the end. We're going to talk about domains to start with, and then we'll talk about domains to end with. And because, like I said, in math we don't like to write out words, we use a capital D for domain. This subscript of f means the domain of f. This one is the domain of g. Some books will use an equals, some will use colon. It doesn't matter. It's the same thing. We're talking about the domain. All right. So before I start, I have to know the domain of f. So I'm looking at f, and I'm looking for two things. Is there any division in that function f? Oh, I don't have to worry about that. Good. Are there any even roots in f? Oh, so that one, you could use whatever number you want. That's all real numbers. We have a symbol for all real numbers in math, and it's an R with an extra line on the left-hand side. So capital R with an extra line. You could write out ALLREALNUMBERS if you want to, but like I said, we mathematicians, we're lazy. We like symbols. G. Uh-oh. Ooh, start working. There you go. There's G. Do you see any division in G? No. Do you see any even roots? Yes. So, we have to warn people. You can't just use whatever number you want here, because if you put negatives in, you're in trouble. And that means we have to tell them x has to be greater than or equal to 0. You can take the square root of 0. You can take the square root of 1. You can take the square root of 3.7 if you want to, because they're not negative. So we start there. Then we do the function operations. So the first thing we want to know is, what are we going to get if we're looking for f plus g? Well, we're going to need 4x plus 7 added to the square root of x plus x. Now this is to show that this is function f and this is function g. I have to figure out whether or not my parentheses are doing anything. They're not. This is addition. When you add functions, you just need to combine like terms. So I'm going to do an extra step here. You wouldn't have to do this step. And just drop the parentheses since it's addition. So now all we have to do is combine like terms. Do we have any? What could we put together? Yeah, that's it. We can put those two together. It's something. So we'll write it as 5x plus 7 plus the square root of x. These could be in any order, you know. We just like to kind of have that square root in the back so it doesn't look too long and accidentally get the 7 under it or something. So now I look at this and I think about the domains, because what they want me to do is tell them what's the domain of f plus g. In order to use f plus g, I can only use numbers that are in both of these. So this one was wide open. Said use whatever numbers you want to, but not this one. It said cutoffs at 0. So to be in both sets, we have to use this as our domain restriction. X has to be greater than or equal to 0. And you can see why, because we still have this square root of x in here, you know? So we have to tell people, don't use the negatives. Not going to work. Now we need f minus g, and that is the quantity 4x plus 7 minus the quantity square root of x plus x. And this one is the one where we have to be careful. The most common mistake made in mathematics is not distributing that negative. We have to remember that this negative is like a -1. You have to multiply it times everything in the parentheses. So this will be 4x plus 7 minus the square root of x minus x. Do we have any like terms? What could we put together? Just the x's again, right? But it's something. So 4x minus x is 3x plus 7 minus the square root of x. And now, domain of f minus g. Well, again, if we're going to put those two functions together, we have to tell them these are the numbers that would be in both sets. So we already did the thinking for this one when we did f plus g. The only numbers that are in both sets are the x's that are greater than or equal to 0. We have to be able to use it in both if we're going to put them together. So f plus g and f minus g. That's it. That was all the math we could do. So these, I'd like to hear more of you and less of me. And we've got let f of x equal 2x squared plus 8, g of x equal x minus 3. What's f plus g? F minus g. More importantly, how about domains? So that's where we start. All right, help me out. We're looking for two things, right? What's one of the things we're looking for? Fractions. See any fractions, any division anywhere in that? Okay, so far we're all real numbers. What's the other one? Even roots. Any even roots? Score! All real numbers. Use whatever you want in that one. Let's try the other one. X minus 3. Any division? Any even roots? Yes, they're both all real numbers. Well, doesn't that mean when we put them together, it's still going to be all real numbers? Yes, that's why we like to get all real numbers. These two are telling us put in whatever numbers you want. So even when we put them together, they're still going to be all real numbers. Oops, not domain. F plus g. So we need 2x squared plus 8 plus the quantity x minus 3. We have anything we can put together? That's it though, right? Yeah. So 2x squared plus x plus 5. At least we can put it in standard form. That's kind of nice. But we're already ready for domain of f plus g because we investigated it. Both of these used all real numbers, so we can use all real numbers. Let's try f minus g, and let's not make the most common mistake in mathematics. What is your middle step that's going to make sure that you don't miss this one? Yeah, just don't forget to do that. It just happens way too often. And what do we have that we can put together in this one? Yeah, except this time it's a plus 8 and a plus 3, so Domain time. What do we put? Yeah, all reals. Works in both. We're good to go. So after a while, you start to figure out, okay, so you're telling me then, if one of these has all real numbers, but the other has a cutoff, I should use the one with the cutoff. Yes, that's why it's called a domain restriction. The ones that have a cutoff are the ones that you're going to have to use. We did add, subtract. There were two more on our list, multiply and divide. So that's what we have left here. The second problem says we're going to multiply and divide functions. Okay, let f of x equal x squared minus 9, g of x equal x plus 3, order f times g and f divided by g and their domains. Start at the end. Let's look at f. Anything there that needs a domain restriction? None. No even roots, no division. All real numbers. Let's go to G. Anything there that needs a domain restriction? No. Oh, they look pretty good. All reals. Now we have to multiply them. Well, just a week or two ago, I asked you how you multiplied those. How do we multiply those? Yeah, FOIL. It's two binomials. Just use FOIL. X squared times x is x to the third plus 3x squared minus 9x minus 27. Can we combine any like terms here? That's all we can do. So now, domain. At any point when we were doing this one step of math, did we suddenly divide out of nowhere? No. At any point when we were doing that problem, did a square root, a fourth root, a sixth root, any even root show up? Well, then it's all reals. None of that stuff happened. But this one, we're ready for a domain restriction, right? Soon as we write it down, we're going to be creating a denominator. So before we go any further, we better warn them away from a number. What number will be bad? So we have to tell them x can't equal -3. And what that says to a mathematician is, you can use whatever number you want. Just stay clear of -3. Well, you look at that and you think, is that done? Because we can't just start canceling. Canceling is a form of division. In order to see division, or in order to use division, you have to see pure multiplication. Those aren't pure multiplication. This has subtraction and this has addition. So the only way we'd be able to see multiplication is if we could tear this apart into two binomials. Oh, that's called factoring. So if we can factor x squared minus 9, then maybe we can cancel. Can we factor x squared minus 9? Absolutely. That's a difference of two squares, isn't it? That's x plus 3 times x minus 3. Did my denominator change? So I don't need a new restriction. All right. Well, now we can cancel. Because we see parentheses. And if we see parentheses, that's multiplication. Did our denominator change? It did in a good way, didn't it? Because it's 1. Well, we can't get any domain restrictions from 1 because there's no x there. So the only domain restriction we needed was don't use -3. Now, if you're thinking, why all this stuff about domain restriction? Because somebody might come along needing this formula for something in the real world, and instead of looking at our math, they do this. Okay, I just need f divided by g. Oh, I can use x minus 3. And they go out there in the real world, and for some reason, they've got to put a -3 in their formula. That's not what this formula was built for. This formula cannot be used if you have an x value of -3. So we have to let people know about that domain restriction. If they were going to follow the math all the way through, they'd be fine. Because here, if you put a number into this formula, and you put a number into our red formula, you should get exactly the same answer. But they're not looking at that. They're only looking at our final answer. All right, let's look at the got it. Let f of x equal 3x squared minus 11x minus 4. G of x equals 3x plus 1. What are f times g and f divided by g and their domains? Okay, start at the end of this. Take a look at f. Any restrictions? None, right? Okay, so all reals. How about g of x? Any restrictions there? Excellent. All reals, all reals. But in the back of your mind, you should be saying, yeah, but they have us divide later, so there's going to be one. But hang on, we'll get there. All right, f times g. Oh, well, that means they want us to take 3x squared minus 11x minus 4 times 3x plus 1. Oh, I don't like it that way. So you have to take 3x squared times both of those, negative 11x times both of those, negative 4 times both of those. I like the shorter one first. Then I have to just distribute twice instead of 3 times. I take 3x times everything back there, 1 times everything back there, and I'm done. Can I do that? Can you do that with multiplication? Somebody impress us. I know you don't like to think about the G word too much, but you learned this in geometry. Do you remember the name of that property? The property that says 3 times 4 is the same thing as 4 times 3. Commutative. Commutative property of multiplication. Yeah. So now let's do the math. That's what we're supposed to do anyway today. 3x times 3x squared is 9x to the third. 3x times negative 11x is negative 33x squared. 3x times negative 4 is negative 12x. And then I can just take 1 times everything. Can we do any simplifying? Yes, this time, yeah, we can. The 9x cubed, no, there's nothing else we can do with that. But we've got negative 33x squared plus 3x squared, so negative 30x squared. And we have a negative 12x minus 11x, which is negative 23x minus 4. And now it's all in nice standard form. So let's look at the domain of f plus g. While we were doing all that math, did division suddenly pop up out of nowhere? Any even roots pop up out of nowhere? All reals. But we're ready for the next one. We're ready. Domain of f divided by g. 3x squared minus 11x minus 4 over 3x plus 1. We already have a domain restriction. And we haven't even really done any math because we have a denominator. So I come over here and I think, all right, when would 3x plus 1 be 0? Because that would be bad. I can't divide by 0. and I subtract 1 from both sides. And I divide by 3. Well, there it is. There's our bad number right there. So we're going to go ahead and write down right now, domain of f over g, x cannot equal negative 1/3. And then we'll have to watch the math, because every step, if we have a new denominator, then we have to figure out what to do. Now, I know you're going to find this really hard to believe, but some people cheat. Some people cheat on their homework. Some people try to cheat on the tests. One of the ways that they try to cheat is by using an app to factor. Do you realize if we put all the time you've spent in your life factoring, it would be 2 full years of school factoring? Honestly, you got to use an app to factor? If that's happening to you right now, we need to talk, because it's possible that when you went through factoring before, your brain just wasn't developed enough for it. But if you and I sit down and do a couple of them, it's probably going to just pop in there and you go, oh, now I've got this. Here's how I'm going to know. You're going to show me an incredibly goofy way to factor that expression that we have on the top. That's how I'll know. Nobody taught you that goofy way. You copied it. That's where you got it from. Here's how we taught you how to factor that. We said, you're really good at FOIL. So here's what you should do. You should remember that this first one, that first number, comes from first times first. So you should write down the pairs of numbers, nice integers, that would multiply to 3. Those have to be your first times first numbers. Then you go to last times last, and you write down all of the number combinations that could possibly work for negative 4. Like so. And then here's what you do. You've got the first times first, you've got the last times last. You need to check outside times outside plus inside times inside until you get negative 11. Outside times outside plus inside times inside. 1 times 4 is 4. 3 times negative 1 is negative 3. That is not negative 11. Negative 4 plus 3, still not negative 11. Negative 2 plus 6, no, that's 4. 2 plus negative 6, that's negative 4. That one didn't work. 12 and negative 1. Ooh, very close. Wrong sign. Negative 12 plus 1. There it is. That's the combination that works right there. These were first times first. These were last times last. And that is where they go in the parentheses. First, first, last, last. That's how you prove to me that you're not using an app. Right there. And no, I'm not going to tell you what the app looks like. Or tell you its name even. Because that would be bad. So now we see what cancels. It's gone. There's our answer. We already warned them about negative 1/3. Did any new denominator show up in these last couple steps? Nothing but a 1. And there's nothing there that we could tell anybody about. So adding, subtracting, multiplying, and dividing, and using our noggin, not an app. That's what we have to do. I give zeros on homework when I see that. A 0 on the test, then you got to come in and your parents got to come in and you get told you're a cheater. That doesn't work either. So none of that. None of it. If you have trouble with factoring, come on in. There's our assignment. I'll let you write it down, and then those that are interested, I will show you the IZOD thing. 70% off and another 20% off. So obviously this got you in the door, right? I mean, everybody sees 70% off and it's like, woohoo! That's a lot of money. But that is how much you get off. What we really care about is how much are we paying? So if we're not paying 70%, how much of the cost are we paying? 30%. So that gets you in the door. And then you see the additional 20% off. But then you realize the bad news about that 20% off. Because if you're not paying 20%, what are you paying? 80%. And if you want to know 30% and 80%, what does it come down to on whatever it is you're going to buy X, you'd have to multiply those two together. So 0.3 times 0.8, yeah, 0.24. Let me put it up here on the TV so you can see it. So if it were truly 90% off, we would be paying 10% off. Everybody see that? It's not 90% off. Is it still a good deal? Well, it was 76% off. Where do you find 76% off? I mean, that's still a really incredible deal, but it's not 90. So, like I said, I would have been really impressed with them if they'd have said, you're going to end up getting 76% off. But it was good that they stopped people and said, no, it's not 90%. So, definitely an educated consumer moment.